uh, interval like this, then you can use this type of notation. All right, last page, a couple of circle problems, finding the area and arc length, actually, of some sectors. Framing the question slightly different here to say the area and the perimeter of this region. The perimeter of this region, both of these, would include the radii that sort of, marks them off here, okay? So we got to find the area, which, once again, is the fraction of the circle times the area of the circle. So the fraction of the circle is dependent on this central angle here. If that's 120, then over here it's 240. So 240 over 360 is 2/3, and that fraction times 144 pi, it leaves me with 96 pi, and that's my area of this sector. The perimeter, again, needs two things, the arc length and the two radii added together. So we do the same kind of a thing, this 2/3 times the circumference. The circumference of the circle is 2 times pi times the radius, so 24 pi is the circumference of the whole circle, so 2/3 of 24 pi is 16 pi. That's this arc length. But the perimeter of the region, like I said, would include these two radii, so 16 pi plus 24 is the perimeter of that region. Same kind of thing over here. We have a little bit less friendly numbers here because this is a weird angle here, 77 degrees. 77 out of 360 is about 0.2139. That's the fraction of the entire area's circle. All right, and so the area of the circle is 4 squared times pi, 16 pi, times this fraction gives me about 3.42 repeating times pi. You could write a decimal approximation of that on your calculator if you wanted to, but I would just leave it in terms of pi. Make sure you put pi in the answer, though. Don't leave it out of the picture. Perimeter, same kind of thing. We did the same fraction times the circumference of the circle. That gives me 1.71 pi just for this arc length here, and then plus the two radii gives me the perimeter. All right, average rate of change problems. And we've got, here's a function. Here are two x values that I want you to use as your region to find the average rate of change over the interval. And so I need to figure, here's my average rate of change formula. F of x2 minus f of x1 divided by x2 minus x1. So this is like y minus y over x minus x. Yes, it is the slope. Don't forget that. This average rate of change is the slope. All right? So you know how to find the slope, but you got to find the two y values associated with the x values that are part of the problem. So you plug in a 5 and you get a 9 here. You plug in a 3 and you get a 1. You can do the math for that. And so there's our two y values. So y minus y over x minus x, 9 minus 1 over 5 minus 3 is 4. That's the average rate of change. It's 4. Okay, a little bit more of a context for the second one. You get a chart full of hours of the day and temperatures of the day. And it's important to always be aware of the context. This is degrees per hour. That would be our average rate of change, which should be described in degrees per hour. That's what the average rate of change or the slope would mean in this context. So between 10 a.m. and 3 p.m., there's 10 a.m., there's 3 p.m. That's a total of 5 hours, okay? If you went 3 minus 10 and got -7, that wouldn't really make sense to say that. So make sure you're keeping the context in mind. And it went from 84 to 98 degrees, so we do that little subtraction there. 98 minus 84 over 5 is about 2.8 degrees per hour. And I should say degrees Fahrenheit, but I'm just saying degrees. All right, so what is the average rate of change between 4 and 7? Well, here's 4 and 7, and it goes from 96 down to 84 degrees. That doesn't mean I change the order. I still want to keep it the same order. I'm going to go 84 minus 96 over, and that's a difference of 3 hours from 4 to 7. So over 3 hours, that's -4 degrees per hour, okay? So that the fact that it's negative is important in this context. It means the temperature is going down, okay? And what is the average rate of change from 11 a.m. to 6 p.m.? All right, and when you do that, you see it's at 11 a.m. it was 90 degrees, and all the way back over here at 6 p.m. it was also 90 degrees. So it looks like there was no change. It's 0. 90 minus 90 is 0. So it's a misleading number, all right? The information that is lost in computing this value is the fact that the temperature